So this is saying that they want me to translate this from algebra, right, to English. So somebody like read this part for me. What is that?
Greater than,
Huh?
greater than,
Read it from left to right.
oh, the whole thing.
Yeah, this just this part right here. I'm sorry, hold on. Let's get that. Just this part right here.
I think it's greater than X.
15 is greater than X. All right, I'll take it. I'll take it. So give me some numbers as an example so I understand you know what that means. 15 is greater than X.
Seven.
5, good. 7, good. All right. What about 16? No. All right. So for me, when I see statements like this, I kind of like to read them in reverse. So I like to read it like this, X less than 15 to indicate that I want all the numbers that are smaller than 15. All right. All right. All right. All right. Uh, so far, I like what I'm hearing. Let's try another one. So in English, this is 15 is less than X. I want this in math. Tell me what to write.
20,
Mm-hmm.
less than sign, I don't know what else you would call it.
Mm-hmm.
20, that's, you want, how would you give people?
So this is right? Mm, yeah. Yep, I agree. Read backwards, you would say X is greater than 15. All right. So is 16 part of this?
Yeah.
Okay. Just checking. All right. All right. So that's a nice little blast from the past. All right. So let's talk about graphing inequalities on a number line, right? Because that's what we're going to get into today. So what number would make the inequality x greater than 3 true, right? Are you thinking x could be 4? That's correct. But x could be 6, 2, or 37, or even 3.001. Any number greater than 3 is a solution to the inequality x greater than 3. We show all the solutions to the inequality x greater than 3 on the number line by shading in all of the numbers to the right of 3 to show that all numbers greater than 3 are solutions. Excuse me. Because the number 3 itself is not a solution, we put an open parentheses at 3. We can also represent inequalities using interval notation. So there is no upper end to the solution to this inequality. In interval notation, we express x greater than 3 as 3 going to infinity, right? So the infinity symbol, that's that sideways looking 8, right, is read as infinity, right? And it is not an actual number, right? More so it's an idea that the numbers can keep growing on and on and on and on with no end, right? Um, this figure is going to show you what a number line looks like, right? So we always have 0 in the middle, and then to the right of 0, we have all our positive numbers, 1, 2, 3, 4, 5, right? And then to our left, we have all of our negative numbers, right? -1, -2, -3, -4, -5, right? And then to illustrate 3 going to infinity, right? We make a parentheses right here, and then we shade all of the numbers to the right. All right, and that's it. Questions on this idea? No?
But the
Go ahead.
third way they show it, the parentheses three comma infinity,
Yeah, that means the same thing.
same thing, but as
Yeah.
they just write.
Yeah, so actually, the parentheses 3 to infinity, that's actually interval notation. So that's a part of what I'm gonna want from you, right? So in this section, I'm gonna ask you for two things. I'm gonna ask you for the graph, right, with the line and the shading and all that. And then I'm gonna ask you for the bottom part where it says 3 comma infinity, right? Yeah.
That would include not three itself, but 3 point.
Right. So if it was not 3, in interval notation, I use a parentheses to represent that. That 3 is not included, you know? Because sometimes you want to start from a number and then go to infinity.
So an interval notation doesn't matter?
Interval notation matters. Yeah.
Yeah, I'm saying like,
Yeah.
how would you show it the interval notation first by default that it says that
Mhm.
if it's in this form,
If it's in that form, it means
then
this.
three doesn't count.
Where 3 doesn't count.
Okay.
But like 3.001, that counts. Yeah. All right. So we use the left parenthesis symbol, right? That's like open parentheses, I call that, to show that the endpoint of the inequality is not included. The left bracket symbol, like square bracket, right, shows that the endpoint is included, right? So the inequality x is less than or equal to 1, right? That's what that symbol means there. Means that all numbers are less than or equal to 1. So here we need to show that 1 is a solution to, right? We can do that by putting a bracket at x equals 1, right? And then we shade all the numbers, right, to the left of 1 to show that all the numbers less than 1 are solutions, right? So there is no lower end to these numbers. We write x less than or equal to 1 in interval notation as open parentheses negative infinity to 1 square bracket, because we're including 1, right? So the simple negative infinity is read as negative infinity, right? So this might be a little bit small. Just bear with me 1 second. Okay. So what I'm saying is that there's going to be a bracket here. That's not a nice looking bracket. Let me try that again. Okay. There's going to be a bracket there, right? And I want to shade all my numbers to the left. That's how I do the graph of it, right? And then my interval notation, right, is going to be negative infinity, open parentheses, negative infinity, comma, 1, square bracket, right, around the 1 because I'm including 1. So I want 1, 0, -1, negative, all the numbers going down. All right? Questions on this? It's good? All right. It's okay. I just want to show you guys all the possibilities. So here we go. Inequalities, number lines, and interval notation, right? Let's start with the first one from left to right, right? So we have x is greater than some number. We're just going to call that a, right? That's going to be open parentheses around the number a to infinity, right? In interval notation, open parentheses a, comma, infinity, all right? So when I'm asking you a question, I'm looking for the graph answer like this, and I'm looking for this. All right. Let's go on to the next one. The next one says x is greater than or equal to a, right? So now that we're greater than or equal to a, we're going to have what? A square bracket around a, right? So it's going to be square bracket, comma, infinity, and all the numbers to the right, right? So right here, square bracket around a, all the numbers to the right, and a, square bracket a, comma, infinity, all right? Let's do the reverse now, right? Let's say that I have x is less than a, right? So for x less than a, I'm going to have a closed parentheses now around the a, right? Because I'm going to from negative infinity up to a, right? So close parentheses around A, right? And I'm gonna go from negative infinity, open parentheses, negative infinity to A, close parentheses, right? You know what? I like how that looks better. So let me do that this way, just so that pops a little bit more. All right. Next, I have X is less than or equal to A. So with less than or equal, now here comes the square bracket, right? So I'm gonna go from negative infinity up to A and then square bracket, right? There we go. And then for the graph, square bracket around where the A is, and then all the numbers to the left. All right. Is there any questions about this? Go ahead. You could, yeah, you could. Yeah, so this is all of the possibilities, right? So essentially what's gonna happen, we're gonna have I don't want to say the wrong vocabulary word. We're gonna have inequalities, right? Which is gonna look like the equations that we did yesterday and the day before. And we're gonna do the same process, right? I want to solve for the variable, solve for x or whatever. So whenever I finish solving for it, the answer is gonna come out to be one of these inequalities. Greater than, less than or equal to, greater than or equal to, right? And then after that, I have to draw the graph and then give me the answer in interval notation. All right, that's it. I want to make a special note real quick. So the notation for inequalities on a number line and in interval notation use the same symbol to express the endpoints of intervals. All right. So whatever's on the graph, the number line, right? You can use the same notation as when you're doing interval notation, so as not to confuse you. Mhm. I'll give you guys a chance to try this, and then we'll jump into it afterwards. I'm just gonna kill the heading right there. Just put that up. So we want to graph each inequality on the number line and write it in interval notation. All right. I'll give y'all, let's say, 2 minutes. Try this out. All right, let's take a look. So for A, right, I have X is greater than or equal to -3, right? If I'm going to draw that on the interval, I am a little bit lazy with the way that I draw my intervals. So generally speaking, you would start at 0. I like to start at the A number itself, right? So I'm going to put -3 here, but I want to indicate that I understand that to the right is positive and to the left is negative, and I do that by including a couple more numbers, right? It doesn't have to be that many, right? I could do like two more numbers. So -2, -1, those are bigger than -3. And then to the left, I have -4 and then -5. Simple. Nothing like special about that. Let me just bear with me 1 second. Let me get another color, right? So now my prompt was that X is greater than or equal to -3, right? So because it's greater than or equal to, I'm going to use a bracket, right? So I want to use the square bracket like this, right? Or maybe like that, whatever. And I want to shade all the numbers to the right that are greater than or equal to 3. Any questions on that? Did you guys get that? Awesome. All right. So let's try the next one. For B, you know what? Hold on. I forgot. My mistake. Interval notation. I want that as well. All right. So -3 is included. So this is going to be square bracket -3, comma, infinity, close parentheses. All right. I forgot to include that part as well. Did you guys get that as well? The interval notation. Awesome. Awesome. All right. Let's try B. Just bear with me 1 second. So I have X is less than 2.5, right? So again, I'm a little bit lazy with the way that I draw my number line, right? Just put that there. So I just like to put my A term in the middle, so 2.5. But I want to indicate that I understand that to the right is bigger numbers than to the left, right? So a number bigger than 2.5, I might say, let's say 3, and then 4, and then 5, right? It doesn't have to be exact. We're not computers, but just to get the idea across, you know? A number smaller than 2.5, let's go with 2, 1, and then let's finish it off with 0. All right. I just want to show that to the left is smaller, to the right is bigger. All right. Let me let's go orange, right? So now this says X is less than 20, excuse me, I'm about to say 25, less than 2.5, right? So I want to use a parentheses, right? So here we go. There's a parentheses, right? That's my parentheses. And then I want to shade all the numbers to the left. Now listen, if you ever on your test, right? And let's say like you get this question and you're like, I can't remember which way to shade. It's a little bit difficult, right? Check this out, right? Our prompt is X is less than 2.5, right? I don't know if this helps, but think of this as like the beginning of the arrow, right? And it's literally pointing to the left, right? So that's the same way that I'm going to shade. I don't know if that helps, but this is something I came up with. Go ahead. Yeah. The dots? Yeah. I got you. I'm getting to that. Yeah, I'm getting to that. But it's actually interchangeable because the dots and the parentheses and brackets, like they're not the same, but they're related. So it's like a little it's interchangeable with it. Let's get to the interval notation now, right? So I'm going from negative infinity, so open parentheses, negative infinity to 2.5, and then parentheses. Right? I kind of like this method because the number that I'm stopping at, the A, has the same parentheses as the interval notation. All right. Questions on this? Everybody got this? All right. Let's hold on a second. I'm sorry, say it again. Yeah, this is an example. Yeah, yeah. Let me grab this last one real quick. Just bear with me 1 second. I gotta like do a little bit of scrolling with this. This is C X less than or equal to -3/5. Just bear with me 1 second. -3/5. I'm sorry? Yeah, yeah. This is me doing them out. Yeah. Because you see, the question was, right? You have these inequalities right here. You want to graph them on the line and give your answer in interval notation. So that's what we're doing. Yeah. All right. So -3/5. All right. So my advice to doing a fraction, right? If you have a calculator, you can verify what 3/5 is, right? You can also do it by hand. Let's do it by hand just to get a little practice, right? The reason why I'm verifying this is because I want to know in between which two numbers does this fall, right? I'm confident that it's going to be between 0 and 1, but let's prove it, right? So your denominator will go on the outside, numerator on the inside. I don't care about the sign for right now. I just want to know what the decimal answer is, right? So 5 goes into 3 0 times. 5 times 0 is 0. Subtract this out. This is 3. Decimal point here is 0. Bring that down. Now 5 goes into 30, what? 6 times, right? And then 6 times 5 is 30. Boom. So boom, I know that that's 0.6. Now I know for fact 0.6 is in between 1, 0, right? So this is kind of like a little trick, a little method to know how to deal with the fraction that you're dealing with if it's not a decimal, right? That being said, I can go straight to my number line now with confidence, right? Same thing. I'm going to start off with the A term, -3/5, right? But I know that it's supposed to be between 0 and 1. So to my, what you call it, to my right, this could be 0, and then 1, and then 2, and then 3. And to my left, this could be -1, -2, -3. All right. Did I lose anybody with this? This makes sense?
I think the
See it again? It's in between -1 and 0. Because it was negative to begin with. I just did the little division to figure out what the decimal point, like what is 3/5? Right, so I know that it's 0.6. And I know that 0.6 is gonna be between 0 and -1. So that's why I did that, you know? Because when I do my number line, I like whole numbers. I don't like this decimal, to the left and the right kind of thing,
Is that an acceptable answer then?
Yeah, yeah. So then now let's do the graph real quick. Let's do green. Excuse me. So this says x is less than or equal, right? So I'm talking about a bracket now, less than or equal to -3/5. So here goes our bracket, all right? And I'm gonna graph this way, all right? Now let's talk about the interval notation. I'm going from -infinity all the way up to -3/5, square bracket because it's included. Right? Did everybody get this part? This one was a little tricky. All right, we good? Good. All right, good? Do y'all want to see another one, or you feel like we can move on? Want to see another one? All right. All right, here you go. Try these out. Literally the same question as before. So I'm looking for a graph. I'm looking for interval notation. All right. Give y'all a few more seconds. All right, so should be good now, right? I have x greater than 2, right? I'm gonna start off with that. You know what? Wrong color. Give me 1 second. So I have x greater than 2, right? Okay, let's do that number line. Again, I like to start off with my a term, so that's 2. To the right, I'm gonna have 3. 4 to the left, 1, 0. Now this is greater than, right? Not greater than, equal to, greater than, so it's gonna be a parentheses, right? So I'm gonna have I'm gonna have a parentheses like that around the 2, and I'm gonna shade all the numbers that are bigger than 2. All right? And then in interval notation, what's this gonna be, right? This is gonna be 2, so open parentheses, excuse me, 2, comma, infinity, and then close parentheses. Everybody got this for number 1? Or A, excuse me? No questions? All right, let's go on to B. Let's go on to B. Now B is literally the same thing, right? I have X is, well, sort of, is less than or equal to negative 1.5. We see how this one has a decimal, right? So I could clearly tell negative 1.5 is in between negative 1 and negative 2, right? That's what I'm trying to say, you know? Anyway, let's get that number line going. So I like my A term to be in the middle, negative 1.5, right? And then to my right, right? Let's see. This should be negative 1, 0, negative 2, negative 3, and negative 4. You get the idea, all right? So now this is less than or equal to 1. So now we're talking brackets. Give me 1 second, please. Let's go pink. All right, so now we're talking brackets, right? Less than or equal to. So, boom, I have my bracket. I'm going to shade all the numbers that are less than or equal to negative 1.5. That's it. All right, let's talk interval notation. This is going to be open parentheses, negative infinity, comma, negative 1.5. Almost changed the problem by accident there. And then close bracket. Boom. That's it. Everybody got this? All right, good. All right, just bear with me 1 second for this last one. I know there's an X, but I gotta scroll up. Greater than or equal to 3/4. Okay. Now, 3/4, I could tell you that that's 0.75, but I recommend if you are unsure, do the division out, right? On Thursday, we don't have calculators, so we're gonna have to do it by hand. But if you were in another scenario, you could just quickly in the calculator, 3 divided by 4 gives you 0.75. 0.75 and those between 0 and 1, so I can proceed right after that. All right? So that's 3/4. Over here, this is gonna be what? Bigger than 3/4. This is 1, 2. Let's make that 3. I'll call this 0, negative 1. Call that negative 2. All right. It don't got to be pretty. You just want to get the idea across. You know. Let me get another color. Let's go with the rainbow. Let's go with the rainbow. All right. So greater than or equal to 3/4. Right. So that's going to be a bracket because it equal. Right. So bracket. And I want to shade all the numbers that are greater than 3/4. So there we go. All right. Let's talk interval notation. All right. Excuse me. 1 second. So this is going to be open bracket 3/4, comma, infinity, close parentheses. All right. Any questions about this? So we good? All right. Let's keep it moving then.
We find the negative 2, 2,
because I want all the numbers bigger than 3/4, right? So this says x greater than or equal to 3/4. So what number's bigger than? So the numbers that are bigger are to the right. Good. And then the interval just kind of matches the graph. Mhm. All right. We got one more scenario that we got to discuss. This is another situation that could occur, all right? So what numbers are greater than 2? Just pull this down so y'all could, if you, in case you're still looking at that. What numbers are greater than 2 but less than 5? Are you thinking to say 2.5, 3 and 2/3, or 4.49999, right, etc., right? We can represent all the numbers between 2 and 5 with the inequality 2 less than x less than 5. So now I'm talking about enclosing like a portion of the graph, right? So we can show that 2 less than x less than 5 on a number line by shading all the numbers between the numbers 2 and 5, right? Again, we use the parentheses to show the numbers 2 and 5 are not included. All right, so boom. This might, I don't know about y'all, but for me, this is kind of not popping. So what I'm trying to say is that I'm gonna have a parentheses here and a parentheses here, and I'm gonna shade in between. That's what I'm saying. All right. And your interval for interval notation will be open parentheses 2, comma 5, close parentheses. And what it means is that I'm talking about all those numbers in between those two numbers. All right. So this idea is a little bit more complicated. So let's do one together, then I'll let y'all try one if you want. All right. So I'm gonna just do A real quick. So one question, 1 second. Let me just get my pen. So for A, I have -3 is less than x, which is less than 4, right? -3 less than x, which is less than 4, right? So now what I want to do, let's draw the number line, right? But I need both of these endpoints to be on the number line, So this is a little bit more challenging, this graph, all right? Okay. This time I'm going to start at 0, right? Then I have 1, 2, 3, 4, 5, 6, and then I have -1, -2, -3, -4, -5, right? Because I want to really show I'm talking about the numbers in between, right? Now, this is -3 less than x, which is less than 4. So it's going to be in between these two numbers, right? Let me go back to the rainbow, right? So it's going to be from here, open parentheses on the -3, close parentheses on the 4, because the -3 and the 4 are not included, right? And it's going to be all the numbers that are in between, right? All the numbers that are in between. In terms of interval notation, this is going to be open parentheses, -3, comma, 4, close parentheses. All right. Questions on this? Make sense? All right, try B for me. Try B for me. I'll give y'all like a minute to try that. So B says -6 is less than or equal to x, which is less than -1. It's a little complicated, but I feel like y'all could get it without me telling y'all. I feel like you might be able to get it. All right, so we good? All right, let's try this one out. So this one says -6 is less than or equal to x, which is less than -1. Okay, so I really, really, really need those points to be on my line, all right? I'm not gonna start at 0 for this, right? Thinking about what I want to do. All right, how about this? How about this, all right? I'm gonna put -1 here. To the right of -1, we know is what? 0. And then -2, -3, -4, -5, -6, and -7. All right. I'm trying to find the laziest way that we could draw this, you know? All right. Let me get a good color. I'm gonna use this color right here, right? So this is -6 less than or equal to x, right? So that less than or equal to is gonna give me a bracket, right? So now we're talking about a bracket. So here we go, bracket. And then it says that x is less than -1. So this is gonna be a parentheses, right? There goes my parentheses. And all I'm gonna do is shade the numbers in between. So, all right. Yeah, I have pencils, so y'all could probably do it better than me. I'm just over here trying. Right? But yeah, that's it. Let's talk interval notation, right? So this is gonna be open bracket, right? Because we're including the -6, all right, all the way up to the -1, but I'm gonna have a parentheses to close it out. All right. Did everybody get that? You didn't get that? What happened? What went wrong?
But I,
The X? You mean like from the original part right here? So what part didn't make sense? Tell me. So X is just always going to be there, right? X is, how can I say this now? X is a variable that's representing all of these numbers that we're shading in the line. So there's no definite X. I'm just telling you that there's going to be a range of possibilities, a range of numbers, and that range is represented by X. All right. So it's about me taking the range or the inequality that's given, change it into the graph, and then given the interval notation. Mhm. So we good? All right, bear with me for 1 second. I gotta kind of scroll up for this next one. So 0 less than or equal to x, and then just bear with me 1 second. So equal 2.5. Hold on, I just want to verify that one more time. All right, there we go. Go ahead. What I'm saying?
that,
Uh-huh.
it was a high, like, big,
Nah, you just do with your pen. No. How I used to do it, you know, like how when the pencil is sharpened, right? Let's see. I mean, you get the idea, right? So when a pencil is sharpened, right? Every time you write, you always write like from the tip, right? Like imagine this is like the piece of paper right here, you know? You always write from the tip onto the paper, right? But if you turn the pencil sideways, right? Like you can actually shade with that, you know? like I put it on like an angle, and then it becomes like a little bit of a wider kind of marking, so to speak. I don't know if that helps, but yeah, yeah, and then just on the side like that. Yeah. All right, let's try this one out. So I have 0 less than or equal to x, which is less than or equal to 2.5. All right, real quick. So, all right, we could try that same method that we did on the last question. I kind of like that method, right? So I had 0 right here. Give me a number smaller than 0, -1. Call that -2. And then let's see what else we have. We're gonna have 1. We're gonna have 2. Then I want 2.5. Then I want 3, and then let's finish it off with 4. Oh shoot, I said 4, but I wrote 5. Sorry about that. All right. So now I just want to do my brackets, do my shading, all that usual. Here's the hard part. I gotta pick a color. You know what? I'm gonna try the purple. I don't know. I feel like the purple might be a little too dark, but I'm gonna try it. All right. So this is less than or equal to, so it's gonna be a bracket. There we go. And then same thing, less than or equal to, it's gonna be another bracket. And all the numbers that are in between. There you go. For our answer, right, in interval notation, this will be open bracket 0 to 2.5, close bracket. And then that's it. Questions on this? Good? All right, let's keep it moving. So now that we got that out of the way, let's kind of bring what we did yesterday and the day before into the conversation a little bit. All right. So we're going to solve linear inequalities, right? So a linear inequality is much like a linear equation, but the equal sign is replaced with an inequality sign. So a linear inequality is an inequality in one variable that can be written in one of the forms ax plus b is less than c, or ax plus b is less than or equal to c, or ax plus b is greater than c, or ax plus b is greater than or equal to c. All right. Let me just define that for you guys a little bit. So linear inequality. So a linear inequality is an inequality in one variable that can be written in one of the following forms, where a, b, and c are real numbers and a cannot equal 0. That's important. All right. So ax plus b is less than c is one form that it can be written in. It can also be written as ax plus b is less than or equal to c. It can also be written as ax plus b is greater than c. And it can also be written as ax plus b is greater than or equal to c as well. All right, so when we solve linear equations, we were able to use properties of equality to add, subtract, multiply, or divide both sides and keep the equality, right? Similar properties hold true for inequalities, right? We can add or subtract the same quantity from both sides of an inequality and still keep the inequality. For example, -4 is less than 2, right? So we have -4 -5 is less than 2 minus 5, or we'll simplify down to -9 is less than -3, which is a true statement, right? You can also have -4 is less than 2. If you add 7 to both sides, this will become -4 plus 7, which is 3, less than 2 plus 7, which is 9, and 3 is in fact less than 9, which is true. Notice that the inequality sign stayed the same. It's important right now, right? This leads us to the addition and subtraction properties of inequalities. All right. Let's get that out of the way. So what we're doing right now, we're just kind of building the vocabulary a little bit, you know? So addition and subtraction property of inequalities, right? So for any numbers A, B, and C, if A is less than B, then A plus C is less than B plus C, and A minus C is less than B minus C. For any numbers A, B, and C, if A is greater than B, then A plus C is greater than B plus C, and A minus C is greater than B minus C. We can add or subtract the same quantity from both sides of of an inequality and still keep the inequality. All right. How are you? Hey, you're welcome. All right. So what happens to an inequality when we divide or multiply both sides by a constant? This that problem right here. This that problem right here. So let's talk about it. Let's first multiply and divide both sides by a positive number, all right? Say I have 10 is less than 15. I want to multiply both sides by 5. That's going to give me what? 50 is less than 75. That's true, all right? Now, let's say I have 10 less than 15. I want to divide both sides by 5, right? That leaves me to 2 divided by 3 is and that's a true statement as well. So the inequality sign stays the same, right? Oh boy, here we go. We're about to get into the issue one, right? All right, so this is our problem one right here. Does the inequality stay the same when we divide or multiply by a negative number, right? So let's say I have 10 is less than 15, and I multiply both sides by -5, right? So I have 10 times -5 and I have 15 times -5. That's going to give me -50 and -75. But is it true that -50 is less than -75? It's not. -75 is actually smaller than -50, right? You rather owe $50 than owe $75, right? So the sign flips, right? How about 10 is less than 15, right? If I divide both sides by -5 this time, it's going to give me what? -2 and -3, right? But which one's bigger? -2 is bigger than -3, right? So the sign flips. So whenever you divide by a negative, the sign flips. If you multiply by a negative on both sides, the sign flips. That's the lesson here. All right. For me, in my coming up, I only really focused on the division one. When you divide by a negative, the sign flips. You know, like I've never had a situation, unless I forcefully do it like this, where I had to multiply both sides of an equation of an inequality, excuse me, by a negative number, right? I just wouldn't do that. You know, it's my thing. Also notice that when we fill the inequality signs reverse their direction. Okay. So when we divide or multiply an inequality by a positive number, the inequality sign stays the same. When we divide or multiply an inequality by a negative number, the inequality sign reverses. This gives us the multiplication and division property of inequality. All right, let's expand on that real quick. I'm sorry? Yeah, yeah. This is gonna be a little bit involved, so just bear with me 1 second, but we'll get through it, all right? It's gonna be a little bit involved. All right, so the multiplication division property of inequality. So for any numbers A, B, and C, you want to multiply or divide by a positive number. If A is less than B and C is greater than 0, then A times C less than B times C and A over C less than B over C. If A is greater than B and C is greater than 0, then A times C greater than B times C and A over C greater than B over C, right? Multiply or divide by a negative, here's the issue, the sign flips, right? So if A is less than B and C is less than 0, then A times C greater than B times C and A less than, oh, excuse me, A divided by C is greater than B over C, right? The sign flips. If A is greater than B and C is less than 0, then A times C less than B times C and A over C is going to be less than B over C. All right? Theoretically, that's what it means, but we all know what that means with numbers. Let me just get one last special note in. So when we divide or multiply an inequality by A, positive numbers, the inequality stays the same. Negative numbers, the inequality reverses. All right. Sometimes when solving an inequality, excuse me, let me say it again. Sometimes when solving an inequality, as in the next example, the variable ends up upon the right. We can rewrite the inequality in reverse to get that variable to the left. So if I have X is greater than A being some number, it has the same meaning as A is less than X, right? So if you ever end up with the n term, right? A is less than X, you can always rewrite it in reverse, X greater than A to make it make more sense. So think about it as if X and if Xander is taller than Andy, then Andy is shorter than Xander. There we go. All right, let's look at an example. That's enough of the theory. So we want to solve each inequality here. Same thing, right? I want you to graph the solution on a number line, and I want you to write the solution in interval notation. Same thing as what we were doing before, all right? Let me try the first one. All right, so I have X, hold on, let me get a pen real quick. I always forget this. I always forget to get my pen. So I have X minus 3 over 8 is less than or equal to 3 over 4, right? Listen, even though you see fractions here, I don't want you to let fractions bother you, right? Fractions are just numbers. Treat them as such. I have X minus 3 over 8 less than or equal to 3 over 4. What am I going to do? I'm just going to add 3 over 8 to both sides and I'm good. That's it, right? Don't worry about no LCD, all of that. Just do what you know how to do with numbers. So I'm just going to add 3 over 8 here. What I do to one side, I got to do to the other. And that's it. So now I have X is less than or equal to 3 over 4 plus 3 over 8. Now we could talk about, let's get an LCD, add it all up, right? So what would the LCD be between 4 and 8? Not 2. I'm not looking for a multiple. What number does 4 and 8 go into? 8, right? They both go into 16 also, you're right. So I'm looking for the least common denominator, but that's a common denominator. You could use that as well. That's not wrong. That's not wrong. You could use that as well. I'm gonna use the LCD just because it's a little bit easier. So to make the 4 into an 8, I have to multiply that by 2. But what I do to the bottom, I gotta do to the top. So now let's talk about what I have. I have X is less than or equal to 3 times 2, what's that? 6 over 8 plus 3 over 8. Now I have the same denominators. I could just add the numerators up, right? So 6 plus 3, what's that? 9, right? So this is going to be X less than or equal to 9/8, right? Simple, simple, simple. And then now that I'm here, hold on. Yeah, now that I'm here, right? We already know what to do, right? Give me the graph, give me the interval notation, simple stuff, right? So I don't feel like doing the division, but everybody could tell that 9 is bigger than 8, right? So 8 goes into 9 at least one time. So that means what? This number is going to be between 1 and 2, right? If what I just said just flew over your head, just do the division, right? Just to prove it. All right. So anyway, right? I'm just gonna start off with the 9/8. Just keep it simple, right? I know it's between 1 and 2, right? So here goes 2, here goes 1. Just keep it going. 3, 0. I feel like you get the idea, right? Numbers to the right are bigger, numbers to the left are smaller, right? And then let's get that graph going. Let's do the rainbow, right? So this is less than or equal to 9/8. So I'm gonna do a square bracket. There we go. And then we're just gonna graph it over just like that, right? Shade it in. After that, let's do our answer. So this is gonna be open parentheses, negative infinity, all the way up to 9/8 square bracket. Right? Questions on this, anybody? Go ahead.
Can you repeat the top?
Sure. So we started off, we had x minus 3/8 is less than or equal to 3/4, right? So same thing as before with the equations, right? I want all my numbers on one side, I want all my variables on the other, right? So what did I do? I just added the 3/8 to both sides, right? Adding doesn't change the sign, right? Negative 3/8 plus 3/8 will just cancel out very easily. And then when we add a positive 3/8 to 3/4, right? That's when we got to have the same denominator. So we find the LCD, right? LCD for us this time was 8. It's okay if you want to find a common denominator. That's fine, right? So if you want to use a 16, or if you felt like, you know what, I can't even figure this out. I'm just gonna do 8 times 4, right? And then see what happens with that. What's that, 32 or something? You could have done that too, right? And then what you move to the bottom, you move to the top, you move to the bottom, you move to the top. The only thing is though, right? When you get that answer, it's not gonna be a nice 9/8. It's gonna be some multiple of it, you know? It's gonna be larger. So you have to reduce it, right? And then when you reduce it, even in the reduction process, now that I think about it, because if you do the long division, it would give you 1 point something. And I know that that's going to be in between what? Between 1 and 2. So that's all I need for the number line. And that's it. You know? Yeah. That's the only hard part is the reduction of it. So that's why we do the LCD. Blah blah blah. So I got the LCD as 8, right? So I had to change. The only thing I had to change was the 4 into an 8 because the other one had 8 already.
That 8 is hard.
Mhm. Right, right. I want them to both have the same denominator at the end of the day, right? The only thing I could have done to the one with the 8 is multiply it by 1, but anything times 1 is itself, so it's just a waste of like thought process. So I multiply the 4 by 2 to make it into an 8, but I have to be fair. What I do to the bottom, I have to do to the top. All right. And then now that gave me the 6/8. And then now I can easily add 6 plus 3 is 9/8. Right? The sign stayed the same. X is less than or equal to 9/8. And then it's just about doing the graph. Now we thought about it and we realized 9/8 is definitely bigger than 1. It's not 2, right? It would be 2 if it was 16/8, right? But it's 9/8. So I know it's just a little bit bigger than 1, right? So I just put my 9/8 on the graph. I know it's between 1 and 2. I added an extra number on the end just so we could tell, to the right is bigger numbers, to the left is smaller numbers. Square bracket and then shade it in. That's it. And then for inequality, I had negative infinity, comma 9/8 to the square bracket. All right.
We can go back.
Okay. Oh, I forgot that I had other ones here. Yeah. Which one? The theory?
In,
Like where? Here? Where at?
addition,
The addition?
we have
All right. Okay. Let's look at the next one. So I have 9y less than 54. My pen.
we do find the addition.
No. Yeah. One of them is addition, one of them is subtraction. Yeah. The two parts you're seeing is like what happens if it's greater than, what happens if it's less than. That's what that is. All right, let's look at this one. So I have 9y is less than 54, right? So I want to get y by itself, same thing as we did last time. So I'm going to divide by 9. Well, you got to be fair, right? Do the one side of the equation, I have to do the other side of the equation. All right. So now I have what? Y is less than, what's 54 divided by 9? 6. Okay. All right. And that's it. We're back to the square one where we were before, right? Let's get our number line going. I'm just going to write 6 in the middle. I have 7, I have 8, I have 9. You get the idea. I have 5, I have 4, I have 3, and I'll even throw in a 2 right there. Boom. Right? This is going to be a parentheses, right? Because this is y less than 6, right? Less than 6. So I want all the numbers that are less than 6, parentheses around 6. Let's shade these in, right? And then for interval notation, right, we're gonna go from negative infinity to 6, parentheses, parentheses. Okay. Questions on this? All right, just same thing as yesterday. Not too bad. All right. Let's get the last one real quick. Just bear with me 1 second. It's gonna be, I have to scroll a little bit in between. So negative 15. All right. Just bear with me 1 second. Negative 15 less than 3/5z. Okay. Sorry about that. Okay. So literally, I'm gonna do the same thing I did in the previous problem, right? Because I want all my variables on one side and I want all my numbers on the other. I'm gonna get rid of that 3/5. Now, whenever you have a number being multiplied times a variable, how do you get rid of it? You do the opposite of what that is, you divide it. So that's all I'm gonna do. I'm gonna divide this by 3/5. But I have to be fair, right? Whatever I do to one side of the equation, I have to do, excuse me, the inequality, I have to do to the other side of the inequality, right? Boom. So let's figure this out. That 15 is a whole number. So this is going to become what? Negative 15/1. And I'm going to do keep, change, flip. Change the division into multiplication. And I'm going to flip the denominator and make that 5/3. Keep the sign, right? Because we divided by a positive number. Keep the sign. So less than z, all right? After this, just simplify it, you know? Remember how we multiply fractions first? We simplify the top and bottom or left and right diagonal, right? So 3 goes into 3 once, 3 goes into -15, -5 times, right? Now, -5 times 5 is what? What's that? Right? -25. So I have -25 is less than z. Now, I don't know about you, but I like my variables to be on the left-hand side, even though I know some of you know how to read this the way it is. So I like to actually read this in reverse. So in reverse, this becomes what? Z is greater than -25, right? So now it's easy for me to see that I want all the numbers that are bigger than -25. Now, if you're wondering why I always graph in such a lazy way, this is the main reason why, right? Because I have a -25. Imagine if I started at 0, I have to do 25 numbers to the left, and I have to do a little bit more to prove that there's numbers smaller than that, right? So instead, make it easy. I just start off at the -25, right? Let me just get a couple numbers to the right, a couple numbers to the left, and we're good to go. So to the right, I'm gonna have what? -24, -23, and I'll stop right there. To my left, -26, and then -27. Right? Just to show that I understand that to the right is greater than and to the left is less than. Right? Now, back to what they asked me before. Let me pick a color real quick. I want to do. Let's do the crimson. Let's do the crimson. I'm gonna try that one out. So I have z is greater than -25, right? Z is greater than -25. So this is gonna be a parentheses because it's not equal to, right? And I want all the numbers bigger than -25, right? So there we go. Parentheses. I'm gonna shade all my numbers to the right. And that's it. In terms of interval notation, this is going to be what? This is going to be open parentheses, -25. There we go, comma, to infinity. And that's it. Questions on this? You good? All right. Do we do y'all want to try one or you feel like we can move on? Because I really want to get to the division one. No? You want to try another one? All right, no problem. All right, you guys try this. So I have P minus 3/4 is greater than or equal to 1/6. I have 9C is greater than 72 for B. And then for C, I have 24 is less than or equal to 3/8M. All right. I give y'all 3 minutes to do this. So solve for the variable. I want you to graph it for me, and then I want you to give me the inequality in interval notation. Everybody good, or y'all need a few more minutes? Good? Few more minutes? All right. All right, good now? All right, let's talk about this. So I have P. Hold on. I have P minus 3/4 is greater than or equal to 1/6. So what should I do first? Right, so I'm gonna add 3/4 over here. But you know I gotta be fair, right? When I do the one side of the inequality, I have to do the other side of the inequality. So I'm gonna add 3/4 over here. All right? So now I have P is greater than or equal to, right? 1/6 plus 3/4. Right? So now I want to know what number does 6 and 4 go into? Easiest way to do this, if you're trying to do it in your head, pick the biggest number. Let's say like the 6, right? Can 4 go into 6 evenly, meaning like with no remainder, right? No, it can't. So double the 6 now. 6 plus 6 is 12. Can 4 go into 12 evenly? Yes, right. So then that's my LCD. That's another way you could do it, right? So now let's say I want to make that 6 into a 12, I have to multiply it by 2. But what I do to the bottom, I have to do to the top. Right? And I want to change that 4 into a 12, right? So I have to multiply that by 3, right? But here's the thing, I got to be fair. What I do to the bottom, I have to do to the top. So my next line is going to be P is greater than or equal to 1 times 2 is 2 plus 3 times 3 is 9 all over 12, right? Let's keep it moving. So this is going to become P is greater than or equal to, what's that, 9, 10, 11 over 12. All right.
P,
Yes, 3 times the 4 and 3 times 3. Right over here. Right? Threes. Yeah. Because my LCD is 12, so I want to change the 4 into a 12, and I want to change the 6 into a 12. So that's why. All right. Now, I'm just going to use intuition. 11 divided by 12, that's going to be between 0 and 1, right? If you're on the test and you want to be absolute sure, do the long division and prove it. All right. So let's get this done. I'm just going to start off with 11 over 12. Right? I know it's going to be between 0 and 1, right? So I'm just going to put 1 right here. Let's do 2. Let's do 3. I'm going to put 0 right here. Let's do -1. Let's do -2. And I'm just going to call it at that. That's simple. All right? So now this is greater than or equal to, so we're talking about a square bracket here, right? We're talking about a square bracket. I'll do the rainbow, right? So now I want greater than or equal to, and we know greater than or equal to is going to the right, right? So close bracket, shade everything to the right. And that's it. All right. Let's talk interval notation. This is gonna be what? Open bracket, 11 over 12, comma, infinity, close parentheses. Questions on this, anybody? Go ahead.
The 12 is 1112. Does it have to be like a number?
What do you mean? It is a number, yeah.
Yeah, is it like 1, 0 and 1, like between the 11 and 12?
Yeah.
It represents the state. That was the thing.
It doesn't represent the space, but it falls in between that, you know? And if we did it in decimal, you would see how close to 1 it is, you know? But we're human. It's in between 0 and 1. That's all I'm looking for. Because I like for my number line to have whole numbers. Right? So I'm not looking for like the most perfect picture. I'm just looking for the idea. You know, that it's in between those two. It's really problems. Nah. All the questions that you're gonna get, like, it's gonna be like this. Like, they're gonna give you, or some work that you'll eventually get to this, right? And then you're just gonna go from this to the graph and then to the inequality. I mean, to the interval notation, sorry. Yeah. Infinity, because the numbers just keep going. I want all the numbers bigger than 11 or 12, so infinity is how I represent all those numbers growing. Yeah.
Even that, and then the arrows are busy.
The end of the arrow, this thing? Right here?
Right.
Oh, yeah, even the arrow. Yeah, I'm trying to indicate that I'm going all the way. Yeah. I don't know, that's just how I do my shading. I do a little squiggly line and then that's it. You guys have pencils, so you guys can do more prettier drawings than I can, you know? All right. That was one of them, 9C greater than 72. Let's do that. All right. So I want to solve for C basically, right? So I'm going to get rid of the number that's in front of the C. So I'm going to divide by 9. But what I do to one side, I have to do to the other, right? So now, what's 72 divided by 9?
8.
Okay, greater than 8. Perfect, right? So now, same thing. I want the graph and I want the interval notation. So here we go. Graph. This is 9, this is 10. This is 7, this is 6. All right. And then where do I want to shade this in? To the right, right? So greater than 8. So this is going to be an open parenthesis. There we go. And then that's it. Now let's talk interval notation. This is the hard part right here, right? So we're going to have open parentheses 8. We're going to go over to infinity and then close parentheses. That's it.
Go back up.
So what, the question? Right?
Yeah.
So basically, I'm trying to solve for the variable. There's a number in front of the C, which is 9. So I just divide by it on both sides. Boom. And then when you simplify 72 over 9 down to 8, then you just graph it. C greater than 8, the sign doesn't change anything. All right. Let's take a look at the last one. So I have 24 less than or equal to 3 over 8m. Sorry about that. Let me just verify. All right. What should I do here? What do you guys think? Right. Right. So it's being multiplied by the m, so I want to divide by it to get rid of it. All right. But I got to be fair. When I do the one side, I have to do the other side.
It's better if I don't use 3/8 divided by 3/8. It's always just automatically turned into times flipped around.
That's fine too. Yeah, that's fine too. Yeah. Matter of fact, that's actually my next step.
Yeah, just
Right,
making sure
because
you can't mess up somehow.
yeah,
Still
nah,
figure
nah.
that out.
The only way to mess up if it was a negative, then the inequality would. Yeah. So now let's see. I'm gonna have 24 over 1 times 8 over 3. And then the sign stays the same, less than or equal to m, right? After this, we're just gonna multiply this, but we can reduce this a little bit, right? 3 and 24 can be reduced to what?
8.
8, right? So 3 goes into 3 once, and 3 goes into 24 8 times. 8 times 8, what's that?
64.
64, very good. Less than or equal to m. And that's it. Now, personal preference, I like to read this backwards, right? So I'm gonna flip this around. M is greater than or equal to 64, right? Call that a mirror image, right? After that, we're back to square one. I want you to graph it. Give me the inequality. I mean, keep saying inequality, but I mean to say interval notation. Sorry about that. All right? So number line in the middle, call that 64. I'm just gonna say 65, 66 is right here. I'm gonna call this 63, 62. Right? And then let's graph this, right? So it's gonna be greater than or equal to 64. So I want all the numbers that are bigger than 64, but it's a bracket though, right? It's gonna be a bracket. So open bracket, excuse me, close bracket. No, open bracket, sorry. Right? And then all the numbers greater than 64. There we go. All right? Okay.
Yes.
Mhm.
We look at the Hartman find for that. You multiply or divide?
So depends on how you're doing. For me, I'm dividing. But when I divide fractions, I have to change flip. So I change a 24 over 1 to multiplication and I flip the denominator to 8 over 3. And then you could multiply straight across and then reduce it. I like to reduce and then multiply. I feel like that makes it easier. You know?
When I was reducing, I ended up finding 6.
Like just 6 by itself?
That wasn't trying to
Yeah.
minus 5 and 6.
Mm,
And multiplied by 8, 60.
no. So look, here's what would happen, right? You wanted to do the 3 into the 24 like this, you know? And then 3 into 24 is just 8. You know? The longer way to have done it, if you wanted to avoid all that, you could just say 24 times 8 divided by 3. So that would have been some large number, right? And then divided by 3, and then we'd have to do the long division anyway to simplify it down into 64. So I'm trying to like avoid doing extra math. That's why I'm doing this. As long as you can get to this part, happy. No, that's all I'm doing. Right.
Why would we like 64 greater than and then
I like to read it backwards, the mirror image, because I feel like it makes it easier for me to graph it. You know, because all of the numbers are bigger than 64, bigger or equal to 64, right? So it just helps me to graph it. That's why.
in the would it still be 64 and
No,
then
M is just a representation of all of those numbers, just a variable
it
representation.
would be
Right. So open bracket first, 64 comma infinity, close parentheses. And then that's it. All right. Let's get to that good stuff now. Yeah. With the different signs, you know? Before we do that, I just want to throw out a warning real quick. So be careful when you multiply or divide by a negative number. Remember to reverse the inequality signs, right? Whenever we divide by a negative, we flip the sign. All right. So let's take a look at this real quick, right? So for A, I have negative 13m is greater than or equal to 65, right? This is the same process as before. I have a number that's in front of the m, right? So I want to get rid of it, right? So I'm going to divide by the negative 13. But you know, right? Whenever I do the one side of the inequality, I have to do to the other side of the inequality. So I'm going to divide this by negative 13. All right. So now what does this become? This becomes m is flip the sign, less than or equal to negative, and then, oh boy, 65 is 5. Appreciate that. Thank you. Negative 5, right? After that, we're right back to where we were before, right? I want the graph, right, on the number line, and I want the interval notation, right? Talk about the graph. I'm just going to put negative 5 here. To the left, negative 4, negative 3. Oh, sorry, that's to the right. I'm sorry. To the left, negative 6, negative 7. Sorry about that. All right. This is going to be a square bracket, right? Because we have equal to. So this is going to be close square bracket, and we're going to shade to the left. All right. Let's talk about interval notation. This is going to be open parentheses, negative infinity, comma, negative 5, close bracket. And then that's my answer. The questions on this, anybody? Good?
No.
Go ahead.
M is less than or equal to -5,
Exactly.
but I don't know why, but isn't every negative number?
Yeah. The larger the number for on the negative side, the smaller the number is. Think of it like you're owing money. It's like at first you owed $5, now you owe 6, now you owe 7, now you know 8. You know, like think of it like that. All right, let's look at B real quick. So for B, and I've never seen this type of question before. I have n over negative 2 is greater than or equal to 8. All right. My goal here is I want to isolate my variable. I want to get rid of that negative 2. All right. So easiest way to do that, multiply by negative 2. But what you do to one side of the inequality, you do to the other side of the inequality. So I'm going to multiply this by negative 2 to get rid of it. But what I do to one side, I have to do to the other. Now listen, I just multiplied by a negative number. So my inequality sign is going to flip. So this is going to become n is less than or equal to negative 16. Did I lose anybody? So because I'm multiplying by a negative, I have to flip the sign, right? And then after this, we're back to the square one. Give me the number line, right? Graph it for me, and then give me the interval notation. All right. So nothing fancy here. I'm putting negative 16 here. Then I have negative 15, negative 14. Let me try that 4 again. There we go. Then I have negative 17 and negative 18. You get the idea, right? So now this is less than or equal to negative 17, negative 16, sorry. Negative 16, less than or equal to negative 16. This is a bracket. So I'm going to have bracket like this, shade all the numbers that are smaller. So let's talk about the inequality. This is going to be open parentheses, negative infinity, comma, negative 16, close bracket. And then that's it. Like we're here? Like you want to see the question? Okay. Yeah. Exact same thing. Solving for the variable and then that's it. So we get the gist of this? Go ahead. Yes, absolutely. Yeah. So we get the idea of this, right? All right, so I'll tell you what I'm gonna do. I'm gonna throw up some more examples for you to do, right? The examples are gonna kind of grow in difficulty with you solving for the variable, right? But try your best. I'm gonna go get you the practice sheet and be right back, all right? So I'm just gonna put a couple of them up for you to try. So in the meantime, try this. Try this out. All right, I'll be back. Just wanna, first example, there's two inequalities here, right? So I'm looking for two graphs and two implementations, and there's one for the other two. Right? Can you help them? Guys, Master BCO, that's any questions about me? I'll be back in a minute.
You. By the usually use the five the difference between these, which is that there will be multiply or divide both sides, we change the direction. It's down, it's scale. We, we, okay. That was that's by -12. Can you also change one in direction? And the thing that's -12 is -180. So k is greater than. Okay. So you have the number line and then you need the integral notation. Square bracket because we're really not saying it. You great. It was equals, greater than equals minus 4, then you would get subtract. There is 12. Equally, like, it- very Yeah. But I think, I mean, depends if the room 120 is like education. One, two. I mean, it's not wrong how we do it, it's just. We usually prefer the.
Everyone, sorry, technology is really, really old. Like some days online this year. It's a little bit longer to print than usual. This is what we're at the game. So it seems live. So,
Yeah, thank you.
is the rest of the game? Absolutely. Sorry. How was this the rest of the day? I mean, I'm gonna go over these still, and then, I have one more, two more examples I wanna do after this. And then this is it for the rest of the day. You know? Just to point something out to you guys about this, right? Let me show you. Just to point something out to you guys about this, and so you see like question one now, right? There's three parts to that, just like how in this example, there's two parts, there's three parts to question one, so three graphs, three interval notations,
And those two is one.
right, these are just one. So even in like this packet, there's multiple of them, right? And then but the ones at the end, there's only one. Right, like the last page is just one.
What happens if you have a, not the, two symbols of inequalities?
Two symbols of inequality? Like, oh, like what's in between two, right?
It's just what happens when you need to say,
We need to graph it.
happens here, this, things like, did you apply over to the other side?
This is negative. Yeah, so that's the like, when you divide everything by negative, it'll flip.
So it'll be like,
Exactly,
whatever.
exactly. All right, let's look at this first example. All right. So I had 8Q is less than 32. I'm sorry, let me say that again. I had negative 8Q is less than 32. Go ahead, what were you saying? Right, I'm gonna divide by -8. You always want to divide by everything that's in front of the variable, right? But what you do to one side of the inequality, you have to do to the other side of the inequality. So now what do I have? I have Q is less than negative, what's that? Say it again? 180? -4, right? Yeah. Okay, this is a simple graph, right? Just gonna put the -4 in the middle, right? Maybe give another number. This is gonna be -3 to the right and -2 to the left, excuse me, -5, sorry about that, to the left, right? And then this is gonna be a parentheses, right? So I'm gonna do open parentheses. That's not included, shading everything to the left. For my inequality, this is what? Open parentheses, -infinity, going all the way up to -4 with a close parentheses. Everybody got that for A? Awesome. All right, let's try the next one. I'm gonna be scrolling a lot, so just bear with me. All right, so I have K over, oh wait, hold on, you said K over -2? Wait, hold on. -12, right? And then the inequality is less than or equal to -15. Is it -15 or +15? 15. Go ahead, what were you gonna ask?
First for Q, for the first problem you did?
Oh, I
Yeah,
was supposed to flip it. Thank you, appreciate that.
Let's go back to that. Let me verify, good. Thank you for pointing that out. It's supposed to be flipped, right? So this part is not right. So what happens when you rush, all right? So it's greater than -4, right? So we should have parentheses here. And then just go that way, right? So for my inequality, this should be open parentheses, -4, comma, infinity. Sorry about that. All right, that's A. All right, we're gonna flip our sign. And we're going to the right. And the reason why we're flipping our sign is because we divided by a -8. So now I want to do K over -12 is less than or equal to 15. So long story short, I want to isolate my variable, right? I want to get rid of that -12. So I'm going to multiply this by -12. But remember, when I do the one side of the inequality, I have to do the other side of the inequality. And now because I'm also multiplying by a negative, my sign will flip. So this is going to become what? K? I'm sorry? Is it 144? Appreciate that. Greater than or equal to? Negative, you said it's 144?
Like,
Oh, but this is 15 times 12. What's that?
no, wow.
The 12 is there. Yeah, it's 12. Oh, these 12s cancel out. That's what you mean, right? And then on the other side, I have to do 15 times -12, which is going to give me a negative what? 180? Okay. I trust you. I'm not verifying it. I trust you. All right. So this is a simple graph as well, right? This is going to be number line -180. Maybe I do a -179 here and a -181 here, right? And then this is greater than, so this is going to be a bracket, greater than or equal to, everything to the right. Interval notation, what is this? Bracket, -180 to infinity, close parentheses. Questions on this? Everybody got this answer? Awesome, awesome, awesome. All right, let's do those last two, and then I have just two more examples after that, and then you guys can work on the practice. So I have a 6y less than or equal to, just bear with me 1 second, 11y plus 17. Now, this is very, very similar to what we did yesterday, right? I want to get all my variables on one side, and then I want all my numbers on the other, all right? I'm gonna let you guys dictate how I do this. There's no wrong answers here. What would you guys like to do first? You want to move the 6y over?
Yeah.
All right, oh, I could do that. So I'm gonna subtract 6y from over here. So now that gives me 0 is less than or equal to, and then minus 6y, because you know what you do one side, you gotta do the other side. 11 minus 6, what's that? Like 5, I think, right? Plus 17. What should I do next? You want to move the 5 back to the other side? All right, so I'm gonna subtract 5y from over here, where I do to one side, I gotta do to the other. So now what do I have? I have -5y is less than or equal to 17. What should I do after that? Divide by -5. Very good, right? Remember, you divide by whatever's in front of the variable, anything, right? But you got to be fair. What you do one side of the inequality, I do the other side of the inequality. So now what do I have? I have y. Well, remember, I just divided by a negative, right? So my sign is gonna flip greater than or equal to.
We, the standard, we,
Let's say it again. Hold on. Got you. So then this is just gonna be negative 17 over 5. It doesn't matter where you put the negative, you want to put it in the bottom, the top, or you want to put it next to it, whatever. It means the same thing, right? This graph is not so bad, right? So I'm gonna do my number line. This is negative 17 over 5. This is an example of what I was saying before, though, right? I don't know which two numbers this negative 17 over 5 is in between. So I'm going to do the long division to figure that out. So if I have 5, and I do the 17 here, 5 goes into 17 how many times? 3 times, right? And 3 times 5, I think, is 15, right? Subtract that, that gives me a 2. Decimal point here, bring that down. Right, and 5 goes into 20, I believe, what, 4 times? And then 4 times 5 is 20. I didn't need to go that far. The point that I needed to see is that I have 3.4, which is in between which two numbers? 3 and 4, right? So what does that mean? That means I have negative 3 right here, and I have negative 4 right here. I could do more numbers out, but I don't need to. That's all I need to show. That's all I need to show. So now this is going to be a bracket because this is greater than or equal to, right? So boom. And I'm just going to shade everything that's greater than or equal to. And that's it. Let's talk about interval notation. This is going to be open bracket negative 17 over 5, comma, infinity, close parentheses. And that's it. Right? Nothing complicated. Questions on this? Or this made sense? 3.4? Oh, yeah. I don't recommend it, but yes, you could use it. Long story short, as long as you show this, you can use it. Also, remember though, like I'm just trying to do simple math here. So I didn't write the answer as negative 3.4, but it recognizes it's supposed to be negative 3.4 period used, right? All right, let's look at that next one. Let me get my pen real quick. Okay. Oh, yeah, we are, of course. All right. So let's look at this one. I have 8p plus 3. Yeah, 8p plus 3. Open parentheses. So now this is looking like what we did yesterday, you know? P minus 12. P minus 12. Bear with me 1 second, please. I'm sorry about this. A lot of scrolling. Greater than 7p minus 28. Greater than 7p minus 28. Okay. I'm sorry about that, right? Okay. So give me 1 second, guys. Go ahead. Uh-huh.
Sarah suggests the meeting over there, but it will be less than how one time one. So let us know when Carol will walk them over. Oh, she could start now, right? That's okay.
It's fine.
Okay.
You already got this.
So none of them have been enrolled from way.
Right, like nobody here has been enrolled yet, right, for classes for the fall. Oh, you do?
You do, okay.
My
And
mistake, I'm sorry.
so who does not have their classes for the fall as of today? Do any of you guys have appointments upcoming with your advisors? No. No appointments. That, we could actually just.
Do you need the class?
You need
for the ID?
to, yeah, you wanna walk them over?
I can do that.
So I'm like, Okay, so there's two that seem to not be enrolled and don't have any upcoming appointments, right? Okay, so I have a clear mentor that will walk you over to meet with an advisor now. If you like, okay? So since it's both of you, I can have both of them, and initially I thought it was fine.
Yeah, I thought so too.
That's fine.
Yeah, I didn't realize.
Okay, so you both will come up, and I'm gonna have, yeah, I'll walk you guys over.
And if
And
you,
advisor then,
if you guys don't make it back in time, like this is all we're doing for the rest of the day, so you guys can do that at home. You know, and if anything, we'll answer questions on it tomorrow or over the weekend, and then we answer questions on Monday, whatever.
yeah, it might not be long, but it's not good right now.
Got you. Yeah, so no biggie if you don't make it back to class, but
Yeah.
you know, that's more important. Oh, yeah, can they get lunch before they go?
Yeah, they can get the snack, there's no rush. If they wanna go and get the snack first, it's not.
All right, so there's snacks in two.
120,
120?
isn't it? I think that's
It is. Yeah,
120.
yeah,
Is it okay, I mean, I can finish that packet for you, so after that appointment, can I just sleep?
yeah, no problem. So, yeah, so snacks in 120, if you wanna grab them, and then right
Yeah.
after, you guys can go do your advising thing. Yeah, whatever you miss, I'm gonna record, so you'll just have it in your email, no biggie, all right? Yeah. Yes, very good, right? That's my first step. Excellent. All right, so now what do I have? I have 8P plus 3 here for P minus 36 is greater than 7P minus 28. All right, very good. So right after that, what do I want to do? I want to combine like terms. Why? Students. Do you have packets? You have packet 1, 2, and 3? Maybe he's leaving it on purpose, I'm not sure. Whatever. All right, anyway, right? Great job. After that, what I want to do, I want to combine like terms, right? Combine like terms. So what are the like terms here? 11P minus 36 is greater than 7P minus 28. Let me try that again. Okay. You guys lead the way. Tell me what to do. There's no wrong answers here. Sure. So how do I move the 7? Tell me what to do. Good. I'm gonna subtract 7P from over here. What I do to one side, I have to do to the other. So now what do I have? I have 4, maybe? So 4P minus 36 is greater than negative 28. What should I do after that? Perfect. Let's add 36 to the other side. What I do to one side, I have to do to the other. So now, what do I have? I have 4P is greater than, what's that? Like 8, maybe, something like that. Yeah. Now, I want to get rid of the number that's in front of the P, because remember, I want the P by itself. Good. I'm gonna divide by 4. But what I do to one side, I gotta do to the other, right? So now what do I have? I have P is greater than 2. Right? And we're right back to where we started. Huh? I'm sorry? The inequality? No, because it's a positive number. Positive 4. If it's negative, you flip it, right? Yeah, that's the key. If I divide by negative or multiply by negative, I flip it. All right? So now let's do the inequality. I mean, why did I say that? Let's do the graph on a number line. I'm sorry. So now I have numbers that are bigger than 2, like let's say 3, let's say 4. Numbers smaller than 2, let's say 1, let's say 0. You get the idea, right? And then I want to do a parentheses here because this is greater than 2, right? Greater than 2. So let's do a parentheses.
the verdict would be like,
It'll be what?
on
To the right, right? So remember that this thing looks like an arrow that's pointing to the right, right? So then I'm gonna shade to the right. Just another way to remember it, you know? In terms of the interval notation, I'm gonna have open parentheses, 2, comma, infinity, close parentheses. Any questions on this? All right, let me just talk about two more examples and then I have you guys go get your snacks and if you finish this, you know, you're good. If you feel like it's easy and you want to do it at home, you have my blessing. You can do that as well. I owe you guys some emails. I'm going to email everybody, I promise. All right. Let me just verify something real quick. Just bear with me 1 second. Okay. All right, let's talk about this example right here. Okay, so here we want to solve the inequality. 8x minus 2 times 5 minus x is less than 4 times x plus 9 plus 6x, right? Same thing. I want to graph the solution of the line and I want to write the solution in interval notation, right? So check this out, check this out, check this out. I'm going to do this one for you guys. All right. So I have 8x minus 2 times 5 minus x is less than 4, which is times x plus 9 plus 6x. All right. So same thing. I want to simplify it, put all my x's on one side, numbers on the other. That's if it's an old one. This is a new question. Yeah, that's it. This one. Yeah. What should I do first? Let's do it together. What should I do first? All right, which one am I going to distribute? Good. Is it just the 2? Right, the 4 as well. But what I'm saying though, is it just 2? Huh? Mhm. So here's what I'm trying to hint at, right? It's not just the 2, it's the negative 2. That's what I'm distributing, right? Bring the negative with it, right? So this becomes 8x minus 10 plus 2x, like that, right? And on the other side, you're correct. Distribute the 4. This is less than, this is 4x plus, what's that, 36? Plus 6x. What should I do now? Tell me. Before that, it starts with a C. I need to combine like terms. I like that. I like that. Right? So I have 8x and I have 2x here. This is going to become what? 10x minus 10 is less than. I have 4x and I have 36 here. Excuse me. I have 4x and I have 6x. Sorry about that. That's going to be 10x plus 36. All right. What should I do after that? All right, so let's subtract 10x from over here. But you know, I got to be fair. When I do the one side of the equation, I have to do the other side of the equation. All right. Bam. So now what do I have as an answer? I have negative 10 is less than 36. All right. So now let me ask you guys a question. Is this true? Is negative 10 less than 36? All right, so this is a true statement, right? Yes, some could be untrue. So if I said that positive 36 is less than negative 10, that's false, right? So when it's a true statement like this, negative 10 is less than 36. Look at your number line. This is your number line right here. I'm gonna start off with 0. It's -1, -2, -3. This is 1, this is 2, this is 3 right here, right? And then I wanna what's it called? I wanna graph it, right? The whole number line, everything gets graphed. Gets graphed right there, right? What is my interval notation? This is gonna be negative infinity to positive infinity. Everything. Because the statement is true, right? It's not true for a particular x less than or greater than or something. It's true for every single number. So this is negative infinity to positive infinity. If the statement was false, then I couldn't do the graph, right? It would be nothing.
Wait, so it's -10, it's -12, would you not be able to?
I would, right? Because -12, like if I change 36 to -12, -12 is smaller than -10. So I couldn't do the graph at all. There would be no graph. And there would be no interval notation there either. Right?
So I just wanted to show you guys that example. You know? Do you guys want to try one or you feel like you get the idea? Because it's just more of the same stuff. All right, let's try one. Here you go. All right, I have one more example after this. But I don't want to keep you guys from the snacks because it's been 15 minutes. So go get your snacks, come back. I promise I won't start till y'all get back, all right? But in the meantime, while you're here, just knock that out. So 120, they have the snacks over there. There's water. I remember seeing Chips Ahoy and Lay's Chips is over there. They have a whole bunch of bars. Nature Valley bars and something else, some fruit bars. Yeah. Oh, say it again? The food. So I don't know, to be honest with you, this week why there's none. In the past, we used to have like sandwiches, like really nice sandwiches, but I don't know what happened. Maybe next week they might give us something. That would be really nice. Tell you something interesting. I don't know if you saw this in your email, Fabricio. So throughout the summer, right? The Art Resource Center, that's one of the places that you can go on campus if you need some type of resource, right? They were actually giving out free lunches on Tuesday. I don't know if you saw that. You know, I didn't see the email until Tuesday night. I'm just like, you know. But yeah.
Oh, they must have, they give you like, that's like match.
Yeah. But it's like a microwavable dinner kind of thing. Like a microwavable lunch. Yeah. Yeah, so they were giving that away on Tuesday. We have pantry on campus. Pantry is like a place you can go to get groceries. It's free. You just go there on the day of pantry and you sign up and then they give you groceries. Pantries happen during the semester, happen on Wednesdays and Thursdays. In the summer, limited staff, so they only do it on Wednesdays, right? It's not every Wednesday, it's every other Wednesday. So the next pantry is actually next week Wednesday. So after the bridge, if you want, you could go over to Lowell Hall. You guys can get groceries, and you can go home with groceries on Wednesday, right, if you want.
The one, yes,
I'm sorry,
the one, the next Wednesday.
it's next Wednesday, yeah. And then not the Wednesday after, but the Wednesday after that, which I believe is the first week of school, not mistaken. That Wednesday, we'll have pantry then. If you want to, there's a lot of other services that they have there as well. I encourage everybody to go there and check them out. If you ever need like legal resources, they have that. If you ever need help with housing or something, they have that as well. If you need help signing up for like SNAP benefits, they can do that as well. They're pretty good over there. Also, if you're willing to walk to the fourth floor, they actually have snacks there every morning, like they have like continental breakfast. Yeah, in Lowell Hall, not this building, Lowell Hall, and you know where the admissions building is? Oh, actually, so when you come on campus, there's two entrances, right? There's an entrance where the cars drive, and then there's an entrance with some stairs, right? So the staircase entrance, the building to the left, that's Lowell Hall.
Oh, that was the
Yeah. So that's where they have all of this. Yeah, so if you're willing to walk to the fourth floor, they have continental breakfast there every morning. Optional if you want to or not. By continental breakfast, I don't mean hot food. I'm talking about like an apple and a granola bar and water or something like that, Maybe some cereal. I'm not guaranteeing that they have, that kind of thing,
Monday, Tuesday.
every day they have it. It's not the greatest, so I'm not like pushing it, but it exists. This is good. This is very good. This is good. This is good. This is good. Is this true? Then we want to compete. So now the next line, we have -9 greater than -30, is that true? Because only $9 is better than only $30, right? So since it's true, then we can grab.
But now we have, it's 9 which is greater than -30.
So it's true.
Like, we either know, I mean,
So
you could, just already did enough,
it's a whole box of
say,
they
they should that's not. Give you the hospital -9 and 35, I think up on the going from -30. But that is clear, that's the only kind of actually going to go to just to know. We don't have 18 of the two day -9
what's the reasonable? Negative positive. In parentheses. So.
In back.
So you got the answer?
Okay, this is -9. Negative 30.
-9 what's that inequality? So. And then you just graph it, all that good stuff. I'll give you guys a few minutes if y'all wanna grab your snacks and come back, no problem. Also, if you wanna grab, come back here. No problem.
Yeah, I want.
I don't wanna wait till 1, but alright, fine, 1 o'clock. I'll stop the recording and then I'll start back. No. I have. Yeah, that's the one that you were doing. I'm just gonna do this real quick and then I'm gonna show you another example and then we'll call it at that. So right here, sorry about that. I have 4, hold on 1 second.
So I have 4b minus 3 times 3 minus b, which is greater than 5 times b minus 6 plus 2b. I'll go quickly through this since everybody's done it, right? I want to distribute the negative 3 on the left-hand side, and on the right-hand side, I want to distribute the 5. So now what do I have? I have 4b minus 9 plus 3b is greater than 5b minus 30 plus 2b. After that, I want to combine like terms, right? So this is going to become 7b minus 9 greater than 5, 6, 7b minus 30, right? And then I want to solve for b, so I'm going to subtract 7b from over here. I'll do to one side, I got to do to the other. So now I have negative 9 is greater than negative 30. Is this a true statement? Yes, it is. This is true. So therefore, what's my number line? My number line is going to be like this, 0 in the middle. I'm going to be lazy because of time, but long story short, you're going to shade everything. And the 30 on the other end? If you want to, you could, you don't have to. As long, but I need you to recognize that the whole line gets shaded. Right? That's important. And then this is going to be what? Open parentheses, negative infinity to positive infinity. And that's it. All right. All right. Last example. Let me show y'all something real quick. Last example.
So every time the truth thing will just draw a line over the tree.
A true statement is the whole line, and negative infinity up to positive infinity. Real quick. All right, last example. All right, so check this out. I have 1 over 3a minus 1 over 8a is greater than 5 over 24a plus 3 over 4. All right. So this is the same, sorry, this is the same thing that we were doing before. Let me grab my pen real quick. Okay, so I have 2, so I'm sorry. I have a 5 where, oh, 5 over 24. Yeah. So 1 over 3a minus 1 over 8a is greater than 5 over 24a plus 3 over 4, right? So first thing I want to do, let's combine like terms, right? So I have, in parentheses, 1 over 3 minus 1 over 8 times a greater than 5 over 24 a plus 3 over 4. Now, in order for me to what's it called? To combine like terms here, they have to have the same denominator. Does 3 go into 8 evenly? No. Let's double the 8 now. 16. Does 3 go into 16 evenly? No. So then let's triple the 8 now. Does 3 go into 24 evenly? Yes. Right? So how do I make a 3 into 24? I have to multiply it by 8. Right? But what I do to the bottom, I gotta do to the top. How do I make an 8 into a 24? I have to multiply that by 3. But what I do to the bottom, I do to the top. So now what do I have? I have 8 minus 3 over 24 times a is greater than 5 over 24 times a plus 3 over 4. Let's keep it moving, right? So 8 minus 3 is what again? That's like 5, right? So 5 over 24a is greater than 5 over 24a plus 3 over 4. Let's subtract the 5 over 24, right, on both sides. Right, so what am I left with? 0 is greater than 3 over 4. Now we all know, right? Having 75 cents in your pocket is more than having nothing, right? So this 0 is greater than 3 over 4 is a false statement. It's a false statement. So on my number line, start off with 0, so 1, 2. I'll go 3, and then this is -1, -2, -3. Do not shade anything. Empty number line, right? This is not true. Go ahead. Well, yeah, you would have to like shade it, like, or you could just scribble the line, just make it so that I can tell what's going on. So yeah, in this situation, this is a false statement. There's nothing to shade. In interval notation, there's no interval for me to give to you. This is it. That's the answer. All right. So that's the last example that I wanted to run through. Do y'all want to try one, or do you guys want to start your break? All right,
No, nothing.
because it's a false statement. All right, so I'm gonna allow you guys another, let's say 35 minutes in your break, because I robbed some of your time. Okay. If you guys want to come back, that's fine. We're just gonna be working on the practice when you get back. If you feel like you understand it and you want to do it at home, go ahead, no problem. I'll see you tomorrow, if anything. And I will get you that email. All right, I just got the final list and everything. I'll get you that email. All right. It's gonna take me a couple hours though to post this, so just like allow me some time to put all of this together. All right.